Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to start with class 9 science chapter number 11 reflection of light. Topics that I am going to cover during this session are light and reflection of light from a plane mirror. What is light? Light is an agent which gives us information about what is happening in our surrounding. It is a kind of energy. Without light energy, you could not see anything. We can enjoy the various wonders of nature like the sunrise, sunset and rainbow only because there is light. Light energy gives things colors, helps plants to grow, can power solar batteries to make electricity, and is used in lasers. It is only because of light that we can see the lush green vegetation, colorful flowers, deep blue skies in the day, stars shining in the dark night. Light is actually an electromagnetic radiation which causes the sensation of vision. It does not need a medium to travel in space. It travels in a straight line. In vacuum, its speed is 3 into 10 raised to 8 meter per second. And it is a transverse wave, means the propagation of the particles is in the direction perpendicular to the direction of the wave. That is why it is called a transverse wave. Light reflects differently from the various surfaces around us. We have already learned that the reflection of light from the smooth flat surfaces as shown over here in this picture is a regular reflection, whereas the reflection of the light from the rough surface is very irregular as shown over here. We need polished surfaces for reflecting light. This is because polished surfaces absorb less light and so maximum light gets reflected. We all are using mirror in our day-to-day life. So now let us understand what is a mirror and how the light is reflected from the mirror. The German scientist Justus von Liebig coated the plane surface of the piece of ordinary glass with silver metal and made the first mirror. Such a mirror is called a silvered glass mirror. In scientific language, a surface which reflects light and creates clear image is called a mirror. A mirror is a reflecting surface. We use various types of mirrors in our day-to-day life. As shown over here in this picture, there are two types of mirror. Plane mirror shown in the first picture and spherical mirror which is shown in the second and the third picture. Let us start with plane mirror. Plane mirrors are used in various activities in our day-to-day life. A plane mirror is made by coating the back surface of the flat and smooth glass piece with a thin reflecting film of aluminium or silver. To protect this reflecting film and to make that side opaque, another coat of the substance like lead oxide is given over it. As shown over here in this picture, you can see this is the mirror, this is the glass surface, and back side of the glass surface is coated with a reflective metal, that is a film of aluminium or silver. And to protect this reflecting film and to make that side opaque, again the substance like lead oxide, the layer of this lead oxide is given over it. We have already learnt about laws of reflection. As shown in the picture, this is the plane mirror. This is the incident ray of light and this is the reflected ray of light. According to the law of reflection, the angle of incidence is equal to the angle of reflection. Over here you can see this is the angle of incidence and This is the angle of reflection. Both the angles are same. Also, the incident ray, the reflected ray and the normal, they are all lying in the same plane. Now let us understand how these laws of reflection are applicable in reflection of light from a mirror. We see a clear image of ourselves when we stand in front of the mirror in our house. To understand that how an image is formed in a mirror, let us first consider an image formed by a point source. Over here, you can see the light rays falling perpendicularly on the mirror. They are reflected back in the same perpendicular direction along the same ray. Now, as shown over here in the second picture, point source O in front of the plane mirror N. Incident rays OA and OB get reflected according to the laws of reflection along the path AC and BD respectively. When these rays, reflected rays, are extended behind the mirror, they meet at the point I. When seen from E, that is from this point, the rays appear to be coming from the point I. Other rays starting from O also get reflected and appear to be coming from the point I only. Thus, point I is the image of the point O. So over here the light rays, they are traveling in all the direction from such a source. Several of these rays, they fall on the mirror. As you can see over here, they get reflected and reach our eyes. Due to reflection, they appear to be coming from a point that is behind the mirror. This point is nothing but it is called the image of the object, that is O. The reflected rays, they do not actually meet. Hence, such an image is called a virtual image. And the perpendicular distance of the image from this mirror is equal to the perpendicular distance of the source from the mirror. That is, the perpendicular distance IN is equal to the distance NO. If we use an external source instead of a point source, an image is formed of every point of the source and thereby forming an extended image of the whole source. As shown in the figure, an extended source AB is kept in front of the mirror M'. The images of A and B are formed at A' and B' respectively. Similarly, the images of all the points between A and B are formed between A' and B', resulting in the image A', B' of the entire extended source, that is AB. The image is A', B'. Let us see an example of this. Suppose we have a flat plane mirror mounted vertically. A candle is placed 10 cm in front of the mirror. So where is the image of the candle located? Yes, this is the virtual image of the candle, which is located exactly at the same distance as the object is from the mirror, that is 10 centimeters. And you can see over here that the rays which are falling from the candle on the mirror, they are getting reflected, and you can see the image when you are looking from here, right? So this is the virtual image of the candle, and it is exactly at equal distance. D0 is equal to Di. Also, the images of all the points from this candle are formed on this side, that is on the virtual image. Nature of image formed by a plane mirror. As shown in the figure, you can see a person is standing in front of a plane mirror. This is the image of this person. The size of the image is exactly equal to that of the size of the object or the person. Also, the distance of the image from the mirror is equal to the distance of the object from the mirror. And if this person will move his right hand, the image of that particular person will seem to be moving his left hand. This is called lateral inversion. Means when we are moving the right hand in the image, we can see that the person is moving the left hand. The interchange of the left and the right side in the image of the object in a plane mirror is called the lateral inversion. Means the image appears laterally inverted in the mirror. Here you can see if the alphabets they are seen in the mirror, they also look laterally inverted. So this is called lateral inversion. Now there is one fact that in order to see full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of that particular person. Let us derive this and understand it mathematically. As shown over here in this picture, an object is placed in front of this plane mirror. Point H, E and F, they represent the point at the top of the head, eyes and a point at the feet respectively. And here you can see this is the image of the object that is formed behind the mirror. If we represent this mathematically, over here you can see this HF, this perpendicular line represents the object. MN is the mirror and H dash F dash is the image of the object. So over here H, E and F are the points that represent the head, eyes and feet of this particular object. So over here R and S, you can see over here R is the point which is exactly at the center of HE, whereas S is the point which is exactly at the center of EF. PQ is the minimum height of the mirror in order to obtain the full image of that particular person or the object. For this, over here you can see RP and SQ are perpendicular to MN. So, if we consider simple mathematical representation, then PQ, which is the minimum height of the mirror, that is equal to RS, and RS is nothing but it is RE plus ES, right? So if we consider RE which is nothing but half of HE. So instead of RE, I can write down HE upon 2. And instead of ES, I can write it as half of EF. So HE upon 2 plus EF upon 2, if we apply simple mathematics, it comes out to be HF upon 2, which is nothing but the total height of the object divided by 2, that is half the person's height. So from this we can conclude that minimum height of the mirror, that is PQ, is equal to half of the person's height. So the minimum height of the mirror must be half the height of the person in order to obtain the full image of the person standing in front of the mirror. This is all about today's session. Thank you so much.